All right, good morning, everybody. Can I have your attention, please? We have 3 sessions coming up this morning before lunch. I'm going to first start us off with an orientation to oh, sorry, we already did one. We already did Anna's welcome. What am I talking about? We did Anna's welcome. We got Jeremy's talk. I'm going to jump now to the orientation to Cryocloud and get you guys starting to see what this thing that you've been hearing about from us in terms of a platform where we're going to be doing our computing and being able to look at the data this week. And then this afternoon, we'll have an intro to the group projects as well. So this is on our the Jupyter book part of the website. So hopefully you guys have all found this part. And it is down under the presentation side, under orientations. And you can follow along if you want. Already have that open. But as I said, my name's Ian Carroll. This is a slideshow that was put together by mostly by Tasha Snow. Tasha Snow is the PI for the Cryocloud project. It is originally Cryocloud. It was for the cryosphere community, was the first group of researchers that got together to put this thing, to create this, and I'll tell you about that and what it is. But now it's much more. So PACE has joined it. Some other scientific communities have joined it. They might actually rebrand the name. They kind of realize Cryocloud's maybe a little bit outdated. But so right now we just think of it as Cryo or Cryo in the cloud. And what it is it's an open science environment in a hosted, or it's an open science conducted in a hosted Jupyter Hub environment. And I'm going to help you guys understand what that all means. We mentioned that this Hack Week has a code of conduct. The Cryocloud community also has their own code of conduct. There's a link there, and this is an expression of the goals of the Cryocloud community, which is to really be a welcoming space to everybody of all varied backgrounds, all varied expertises, and they're very committed to providing a friendly, safe, and welcoming environment for everybody. It is an open science community, and they really look forward to welcoming everybody in. So Cryocloud is meant to help you accelerate your science and make open science easy. It is a computing environment in the cloud, and because the computing environment is in the cloud, if you have access to cloud-optimized data, you can find that things you are used to doing can happen 1 to 2 orders of magnitude faster. A lot of stuff has to come together to make that really sort of pop for you to see it, but it is a promise that's out there for doing cloud computing. It's also about making collaboration easy. It's about eliminating technological bottlenecks in terms of getting your compute environment set up, in terms of getting access to the data. And it's customizable. Everything can be changed, and you can make it suit your analysis, and you can then reproduce whatever compute environment or customizations you've done, either locally on your own laptop, on an HPC, in some other cloud. So it's very portable, and that is part of it also being part of the open science movement. So what I want to get through just today for the next 20 minutes is just a little understanding of the opportunities and challenges of working in a cloud environment, learn a little bit about the technical tools needed, and then do a little walkthrough to get you started. We all did this. Thank you guys. You did a great job. I pestered you a little bit, but it worked. So we're all signed up. Everybody's in. Thank you for filling out the forms. So NASA has been doing open science for a long time because NASA has been making data free and available to the world for a long time. But we have recently sort of come through a little bit of a revolution at NASA and a lot of, sort of not driving it, but, following along this revolution, not only just to how we have open data available and free, but how we can actually go sort of like full steam ahead into open science where the whole process becomes more open. And one of the aspects of this that's really new is this idea about open source science, where you're making, whenever your project involves some code or environment configuration or special ways of doing things, that it's becoming much more common for a lot of us to just work in the open. Just get it up there in an environment on GitHub, on some other platform where other people can see, where we can work and learn with each other and from each other. And this has really accelerated the rate at which people can do this, manage this transition of trying to go from sort of like a more local, a laptop-based sort of compute environment to working in the cloud, because they can really see how other people are doing it. So what is the cloud? Well, I mean, it's It's servers, right? So like you're used to working on servers probably at some point. You maybe you worked on an HPC where you had to log into some other machine. So you understand that it's this idea of it's a computer that you're working on that's not the one sitting in front of you. You're using the internet and you're connected to a computer, right? So I mean, the cloud is servers, but it's also the cloud we work with today is more agile and more complicated and really much more useful in the end than a sort of a traditional just like log in to an HPC approach. We'll talk about things like instances. And so when you are using our Cryocloud platform, it's not just some computer that's been sitting there with all, just like a more traditional HPC. You get a virtual machine spun up that's customized for you. And it's this system that can spawn lots of these different virtual machines. So the way compute is operated in the cloud is a lot different than even the traditional sort of like laptop server model that you might be used to. Storage is very different. Things aren't just in file systems in a big hard drive in the cloud somewhere. Things are a little bit different. So there's some learning, and what it means is that understanding your workflows, you kind of have to reimagine some things, and part of what we're doing here, in addition to taking advantage of this cloud platform to analyze paste data, is to, for some of us, confront it and understand what some of those differences might be. The dream about all of this, which NASA has really delved into with the Earth Data Cloud, is to become a digital watering hole. So the idea of the digital watering hole is getting away from this idea of silos, where when you need the data, you download it to your computers, or you download it to your servers, or you're working with data that's in the ocean biology DAC, and somebody else is working with data that's in the physical oceanography DAC, and things are separated. The idea of Earth Data Cloud is to be the watering hole. It's the one place that everybody comes to. So we all can find the same data in the same cloud environment, and if we are in the compute system that accesses it, then we've got it all. Open science has been around for a long time, where people are doing more to make their whole process, their whole scientific process, from sort of conceptualization to doing some data analysis to drafting a paper to submitting a paper, all doing it in a place where you can sort of easily reproduce it. You can find it somewhere on the cloud platform. You can easily reproduce it if you have access to a cloud platform, and you can sort of learn from it in real time a lot of the time. A great example of that, there's a link in this slide to a course, but also this course had some student projects. And if you go to that course site, you can find all these student projects where it really showed how they do this, how you can reproduce, how you can see and reproduce everything that students did for their projects in a really sort of agile and cloud native way. And it is not coincidence that the person who did this is Fernando Perez, because Fernando Perez is sort of a core person in the history of the development of Jupyter and IPython. He's considered the author of IPython, which is the predecessor to Jupyter. And it can be surprisingly cheap. A lot of people worry that the cloud is expensive. Compute on the cloud can be surprisingly cheap. So that's another good thing to know. It does need sort of figuring out some new spaces and organizational models. There is, I'll call it an organization, it's almost a movement, known as OpenScapes, really designed around helping researchers figure out how to transition their workflows into the cloud. So we go away from Sad Skunk and Sad Bunny, and who are sad scientists working on their lonely laptops, and we take them into a lush land. I love the artwork from this. It's by Alison Hort. Anyway, you should all learn to know a little bit more about OpenScapes and check it out. But one of the things OpenScapes did in the early days was figure out, we need to figure out how to make cloud computing more accessible and easier for scientists. They teamed up with 2I2C, the International Interactive Computing Collaboration, which is a nonprofit that has so much expertise in figuring out how to do stuff in the cloud and make these online computing platforms accessible and user-friendly and workable, and they do the things you want. So OpenScapes started working with 2I2C. They figured out how to make things like Cryocloud. OpenScapes has their own thing that's kind of a mirror of Cryocloud, more as a training platform. The Cryocloud community said, we want that for our science. We want to do our science in the cloud. So they made their own sort of like copy of this thing that OpenScapes and 2i2c invented. And that was where Cryocloud was born. It was born by researchers learning from OpenScapes and saying, we need this platform for ourselves. And its goal is to be a simple and cost-effective managed cloud environment. So managed is an important part. Somebody else, 2i2c, and the people that run Cryocloud have figured out how to get it mostly just the way you like. With you get to do customizations if you need them. It's for training, but it's also for transitioning user workflows to the cloud. It is designed to be a cloud platform with bumpers. So you can not worry about, so we're all working in the cloud. It is a commercial cloud ecosystem. It is running on AWS, Amazon services. You cannot worry about, incurring extra cost, incurring too much costs or something like that. It has enough bumpers to prevent anybody from doing that. One of those things is you'll see, like when we first log in, you're going to be working on like a fairly dinky computer, and that's because we're learning. When you don't need a dinky computer anymore, when you need a big high-performance computer, we have access to that. You do it. But when we're getting started, we're just working on something that's like pretty small and not like super performant. And there are, yeah, I can keep going. Skip this. And let's take it for a test drive. Hub.cryointhecloud.com is where we're going to go, and we'll all have access to it now because everybody's gotten signed up. And I do want to point out that if you do a Google search for Cryocloud, which is how I usually get there, Cryocloud, don't go to the top result. Cryocloud is a private, maybe intelligence company. I'm not exactly sure. But there's something else called Cryocloud, and if you go there, you'll be very confused. So don't go to this one. Go down to Cryo in the Cloud. That's the thing you're looking for. They have this landing page, which is the one Google finds, and I'm just telling you that this is a little bit outdated, but it's still, the search engines haven't caught up, so it is here, but if you scroll down, there is a link. You're just looking for this Cryocloud thing. And I was already logged in, so it just jumped right to the machine that was already open, and I don't want to log out because I don't want to log out. Oh, but I'm going to, I thought I was in an incognito window. Oh, but you're also in an incognito window. You tricked me. Yes, it won't kill your server. Can I not have two incognito windows? Oh, like Safari? Yes, good plan. Okay, Cryocloud. Not that one, this one. Oh, see, I did it. Okay, so this is the login page. And when you do this, when you do the login, it takes you to GitHub. And so this is why I've been forcing everybody to like get me their GitHub username, because this is how we authenticate. The authentication doesn't have its own authentication. It's just based on membership in the Cryo in the Cloud organization on GitHub. So that is why we have this jump from Cryocloud to GitHub, and then it immediately takes you right back to the Cryocloud platform after you get logged in. So feel free to be doing this along with me. You don't have to if you are savvy with this and you've already done it, that's fine. But if you're doing it for the first time, it's probably a good idea to get in there and make sure it's working, because we're going to take advantage of using it right away. Once you get in, we are going to see. Yes, once we get in, once you're logged in, you'll have the, brought to this page about starting your server. So we're all individually working on separate instances in the cloud. And what we want to do in particular, and this is written as well on our orientation page, when you get to the server options page, we want to use a custom image. So we have something that's set up just for this hack week. Actually, I use it for most of my computing now because it has everything we need to do ocean color stuff. But it is our own custom image, and so that's what we want to use. And for getting started, I would select the second option in terms of the amount of RAM available. That should get you through. You'll find that there are some things that we do later on this week that require a little bit more memory. I don't think it's today, but maybe today. But it's fairly easy to start. You're gonna need more?
Yeah, 14 would be better at least.
Oh, for yours. Okay, so for today, then go ahead. Normally I'd say, just especially when you're learning and starting, just like use the small one. It'll start up faster, and it costs less. But yes, for today, I guess go ahead and do the 14 option because we'll be doing some visualizations, and that should make it go. The text here, if you can read it, is also copyable from the thing. And fortunately, once you type it in once, ghcr.io/nasa/github/oceandata-notebooks. Once you type it in once, the Jupyter Hub platform will remember it. So you'll keep seeing it.
Can I do one quick thing?
Yes.
If you copy and paste that link and there's a space after latest, you're going to get a spawn error. Just delete that space and you're going to get the answer.
So.
Thank you.
Great tip. It is a little picky. You have to get the no extra spaces when you're putting this in. So I see, yeah, Anna has 2 here, so now I have to guess which one doesn't have spaces.
Yes, I did it this morning.
This is what happens when spawning is in process. And it can sometimes vary in the amount of times that it takes. So I chose a light instance so that I could get mine going. So it went pretty quick. If you did a bigger instance, it might take a little while. It's not very repeatable. It kind of depends on other people's use. Sometimes there's hardware available right away and your system comes right up. Sometimes you're starting at a time of day when nobody else is using this system and it takes a while to wake up. So rather variable there. Be a little patient. It can take a minute or 2 sometimes. OK, so here we are at the landing page. And I'm just going to keep talking. Some of you guys might still have servers spinning up. We will try to split your attention a little bit. Just wait for that server to come up. Hopefully, it'll be ready by the time Anna gets you started. And I just want to give you a little bit of an overview of what we're looking at now with this platform, and then show you just a couple important guide rail options. So we've landed at what they call the launcher. And most of this launcher space is where you choose what you want to do. You're going to be wanting to use one of these things on the right here, the notebook or console, or we often end up using the terminal, which is down at the other section. All of these are important tools. Over on the left is kind of your general navigation. You do have your own file storage that is persistent. It is this list of folders here are things that are going to show up every time you log in. And anything you put in here will stay here. It'll be back the next. You can shut down your server and come back 2 weeks later, and it'll still be there. It's not going anywhere. You have also some access to some things that are called shared. And so those are folders where everybody has access to. So most of this stuff is private. But if you go into shared, those are things that we all see. Everybody sees the same stuff in shared. And there's shared and shared public. Shared public, you can read and write to. So you can put things in shared public. And there is a Pace Hack Week folder in shared public that we have put some stuff in for us all to use. But you can go ahead within shared public and create any folder you want for your group, for your personal stuff. If you want to share things, that's what it's there for. Shared is bright protected, so you can't touch it. But there's some things in there that is just resources for the Cryocloud community that you can look at. There is a couple other things over here on the left. One of them that we'll find is important is this little graphical user interface for doing things with Git. So that's the icon on the left. Let me make my screen a little bigger. So that's this one over here. And if you want more space, you'll see something I just demoed is if you click on this, it kind of hides the side panel, but you can click on anything over here to get things back open. So this is your folder system. And this is your Git control panel here. And when you do anything like creating a notebook, you'll see corresponding actions happen in your file browser. So this untitled.ipynb is the new notebook that just got created. And there's just so many features to discover as you're learning about the platform that I'm not going to try to go through them all. But if you have questions about any of it, please feel free to approach any of the mentors. We're all getting very familiar with this Jupyter Lab instance right now and can tell you all about the cool future things it can do. One of the most important, though, features is at the end of your day is to know that you have a responsibility to come down to your hub control panel. So if you go to File and go down to your hub control panel, then you can see information about what your one server or possibly multiple servers are doing. You can run multiple instances. But the most important thing is the stopping. So this computer will keep running for a limited amount of time, but when you're done, just go ahead and stop it. It just frees up resources for other people and reduces costs. So when you're done, go click the Stop My Server button, and next time you need to get started, you'll come back and launch a new one, and everything, all your code and stuff will still be there. So that's what it looks like. And can I see if anybody was unable to get in at all? Did anybody, you're totally stuck, so I'm going to come help you. Is anybody else, James?
I asked for too much. That's fine.
So you're unable to get in, and I'll come back and help you. Anybody else totally unable to get in past the login? OK, cool. All right, a couple things then in terms of housekeeping. So I showed you that you do have personal storage space. It's a good idea to try to keep that small. We recommend keeping it less than 10 gigabytes. Storage is the thing that costs the most in the commercial cloud, especially this kind of storage. Storage for the Earth Data Cloud, like where that data is fairly cheap. But this kind of storage that's a lot like an actual file system that you can access anytime you want is a little bit more expensive. So this is the one thing where we do ask people to try to keep it light. We're going to work towards processes where you learn about accessing the data that is remote without never needing to put it in your own storage. So we're going to see about how you're thinking like, well, how can I only use less than 10 gigabytes? I'm analyzing remote sensing data. You're accessing the data without actually copying it to your own machine. So that's how that works. If you start getting interested in using Cryocloud for your stuff, you want to do some stuff, that's fantastic. And we all have access to this after this Hack Week. This is not something we're taking away from you. You're part of the Cryocloud community now by participating in the Hack Week. So you can keep coming back to it. If you find you're suspicious that you maybe are really using a lot of resources, we would really love it if you start looking into providing funding for Cryocloud. So you can include in grant proposals, you can include money. You can also go and apply to Amazon for cloud credits. So Amazon accepts proposals for people that are interested in doing nonprofit kind of things, science and nonprofit. And you can get a proposal and get some credits from Amazon and transfer them to using it to Cryocloud as well. So that kind of stuff is certainly very appreciated if you find it to be a useful resource. The shared public folder is publicly writable, which means you could delete somebody else's stuff. So don't delete something that's not yours. If you put something in shared public and you want to delete it, that's fine. If there's something in there that you're like, what is this? I'm getting rid of it. Don't. That's somebody else's stuff. Stop your server when you're done. It will automatically log off after about 90 minutes, but that's 90 minutes wasted. So just go ahead and stop your server. There's a lot of troubleshooting help. book.cryointhecloud.com, docs.2i2c.org. These are both great sites. You have access to the Slack. That's not just the PACE Hack Week Slack. That is the Cryocloud community Slack. There is a channel called Hub User Questions. You can ask Hub User questions there. The cool thing about us all using the same platform and being interested in open science and sharing what we're learning about how to do code is that everybody is willing to help. So you will find expertise at your fingertips. And then, if something is really, we always have email as well. So you can email cryocloud@minds.edu if you're just like totally hung up on something, or you want to ask about, hey, how can I contribute funding to Cryocloud? If you do publish something or just want to mention it on your GitHub project, please mention Cryocloud. They have a Zenodo page, a Zenodo DOI, so please cite them. They are eager to get your recognition. And thank you. And I am going to help Suzanne, and I'm going to first take questions, and then I'll turn the mic over to Anna. Questions? Yeah.
What's the recommended data limit for a shared public? Like, how much do you think we could put on there before, like, it becomes a problem? Or like, or what's your recommended, like, don't go past this?
I'll pull a number out. I'm not exactly sure, and I'll peek on the best practices page in the Cryocloud book, but I'll say for now, like 100 gigabytes. Like, that is not our big data storage. We have another option that we'll show you about for our bigger data storage, which is we want to be able to write data to buckets.
But 100 gigabytes for everyone, right? Not per person.
No, I mean, like, if you're putting something in there, don't put in more than 100 gigabytes. That is not a per person limit. And it's probably something like we'll clean up after the hack week. But like, while you're working during the hack week, you can be a little more flexible. But we're at the end of the hack week, we can see everybody's storage, and we'll be contacting people to clean up. Comment on that?
Yeah, a comment on that. So one thing that the Cryocloud administrators have that takes them a lot of time is, like, after an event like this, going back and looking in the shared drive for data that hasn't been cleaned up. And so, like, we'll remind you also to clean up that shared drive just to save their admin. And then if you do have a need, like, because this is a resource for you to use beyond this hack week, there may be data that you do need to have available to your team. And so you can talk with us about better options if you have a large data set that you need to have access to.
Thank you. Eli, I think there was another question back here. Yeah.
Yeah, I want to know if this account of Cryocloud will be available after this meeting.
Yes. You have access to Cryocloud going forward, and you're encouraged to use it.
So, according to what you said, cloud is not 100% free. How to pay if we need more space?
So the basic service tier is, covered by contributions from the missions that are involved in Cryocloud, including PACE. ISAT2 is another big funder. So the missions are sort of paying for sort of the baseline availability. If you see that you're going to do an entire processing of an entire 10 years of some data stream, if you're going to do something big, or another instance is, right now it's a little protected from everybody, if you're going to be doing some GPU computing, those are the sorts of things that cost Cryocloud a little bit more, and they're very interested in if you can contribute funding in some way. It's not like a pay by the hour kind of use thing. It's a write it into, if you're going to be using it, write it into a grant. Talk to your organization, see if there's a way that they can chip in some money to help cover the cost of Cryocloud.
We're talking about like $1,000, $2,000, not like $10,000.
Right. Yeah. Thank you. It's always surprisingly cheaper than you might think. It is, yeah, we're talking thousands of dollars at most. Okay. Great. Thank you, everybody. Is going to do some science. Thank you.